In 10 seconds, 200 bullets strike and embed themselves in a wall. The bullets strike the wall perpendicularly. Each bullet has a mass of 5 grams and a speed of 1,200 meters per second. What is the average change in momentum per second for the bullets? Determine the average force exerted on the wall. Assumes the bullets are spread out over an area of 3.0 times 10 to the power of -4 meters square. Obtain the average pressure they exert on these regions of the wall. To find the average change in momentum per second for the bullet, we now assume that the bullet is moving to the right, and we take the right hand side as a positive x directions. The rate change of the momentum is delta p over delta t, where the delta p is m delta v. So that means the change of the momentum is due to the change of the velocity of the bullets. The mass of the bullet won't change. The mass for one bullet is 5 grams, or 5.0 times 10 to the power of -3 kg. But now we have 200 bullets, so we multiply this 5 grams with 200. Delta V is the change of the velocity. The final velocity for the bullet is 0 because the bullet will stop when it strikes on the wall. And the initial speed for the bullet is 1,200. So we use a final velocity minus the initial velocity. We have 0 minus 1,200. The delta t is 10 seconds. Because for the 200 bullets to strike on the wall, it takes 10 seconds. So we divide this delta t, which is 10 seconds. Now we obtain the change of the momentum per second for the bullet is equal to -120 Newton. The unit for the rate change of momentum is Newton, which is the same as the force. And the negative sign is because of 0 minus 1,200, we obtain the negative. So that means the momentum change, the average momentum change for the bullets is points to the left hand side. The negative sign means that the directions of this change of the momentum is points to the left hand side. Delta P over delta T, or the rate change of momentum, it is equal to the force. So this -120 Newton is the force act on the bullet by the wall. Now the part B asks us to find what is the average force exerted on the wall. So according to the Newton's third law, the average force exerted on the wall by the bullet should be the same magnitude as the force act on the bullet by the wall, which we obtain in the part 1, 120 Newton. And the directions should be opposite with this one. So that means here we have negative, then here we will have positive. So this positive means that the force act on the wall by the bullet is points to the right hand side. Part 3, we want to find what is the average pressure the bullets exert on the wall. The area of the contact when the bullet strikes on the wall is 3.0 times 10 to the power of -4 meters square. This is the areas of the regions that the bullet strikes on the wall. So now we want to find what is the pressure act on the wall by the bullet. Pressure is equal to F over A. where the F is a force exerted on the wall by the bullet, and A is the areas for which the bullet strikes on the wall. From the answer of the part 2, we already know that the force act on the wall by the bullet is 120 Newton, and it is points to the right. The areas is given in the equation as 3.0 times 10 to the power of negative 4, so we substitute here as a value of the A. And finally, we obtain the value of the pressure is equal to 4.0 times 10 to the power of 5 Pascal.